Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. When organizations store vast amounts of data in Amazon S3, the challenge becomes how to extract insights without building heavy infrastructure. Two AWS services, Amazon Athena and AWS Glue, solve this by enabling query-in-place analytics and data preparation with minimal setup. Athena provides serverless SQL queries over S3, while Glue offers cataloging, schema inference, and ETL extract, transform, load capabilities. Together, they allow companies to construct governed, cost-efficient data lakes that can be queried directly without provisioning clusters or moving data. This democratizes analytics, enabling engineers, analysts, and developers to work with S3 data seamlessly. Amazon Athena is a serverless query engine that lets you run SQL queries directly against S3 data. There are no servers to manage, and you pay only for the data scanned per query. This design makes Athena ideal for ad hoc analysis, troubleshooting, or log exploration. For example, a security analyst can query CloudTrail logs stored in S3 to identify unusual activity, or a developer can quickly analyze ELB logs without loading them into a database. Athena eliminates the time and cost of provisioning infrastructure for lightweight queries, making insights immediately accessible. Common use cases for Athena include analyzing application logs, security events, and business data stored in flat files. Organizations often use it as a first step in building dashboards or data pipelines, because it allows queries to be run without ingesting data into a data warehouse. It is particularly useful for one-off investigations where setting up dedicated infrastructure would be wasteful. For instance, finance teams may use Athena to run quick validations on daily transaction exports, while data engineers explore raw ingestion before committing to structured pipelines. Athena supports multiple data formats, with performance strongly influenced by the choice. Raw text formats such as CSV or JSON are supported but inefficient, as each query must scan entire files. Columnar formats like Parquet or ORC, however, store data by columns rather than rows, allowing Athena to scan only the necessary fields. This reduces both cost and runtime. For example, querying a single column from a billion-row dataset in Parquet format is dramatically faster and cheaper than the same query in CSV. Choosing columnar formats is one of the most important best practices for Athena. To optimize further, datasets should be partitioned. Partitioning organizes data into subdirectories by fields such as date or region. Queries can then prune irrelevant partitions, scanning only the necessary subset of data. For instance, log data partitioned by year, month, and day allows queries targeting a single day to scan only that folder instead of years of history. Without partitioning, Athena may need to scan the entire dataset, inflating costs. Partitioning is therefore both a performance and cost strategy, critical to scaling Athena queries efficiently. The Athena cost model is straightforward. You pay per gigabyte of data scanned. This means that storage itself in S3 remains inexpensive, but inefficient queries can drive up costs quickly. For example, querying uncompressed JSON across terabytes of logs could be expensive, while properly partitioned Parquet files might reduce the scanned data by orders of magnitude. Awareness of this model encourages architects to structure datasets thoughtfully, ensuring that every design decision directly affects both speed and budget. AWS Glue complements Athena by providing the Data Catalog, a central repository of metadata about datasets stored in S3 or elsewhere. The catalog organizes data into databases and tables, describing schema, partitions, and file formats. Athena uses this catalog to understand how to interpret raw files. Instead of treating S3 objects as opaque blobs, Glue enables them to be queried like structured tables. This catalog becomes the backbone of data governance, providing consistent definitions for queries across teams and tools. Populating the catalog is often done with Glue crawlers, which automatically scan S3 data, infer schema, and populate table definitions. Crawlers can detect partition structures and update the catalog as new data arrives. This reduces manual overhead and ensures that schemas remain current as datasets evolve. For example, if a new month of logs lands in S3, a crawler can detect the new partition and register it automatically, ensuring queries remain accurate without intervention. Crawlers bridge the gap between raw data and usable metadata. Beyond cataloging, Glue supports ETL jobs, which transform and prepare data for analytics. These jobs can run using Spark for large-scale distributed processing, or Python shell jobs for lightweight tasks. ETL workflows might convert CSV logs into Parquet, clean malformed records, or enrich data with additional fields. By running these transformations within Glue, organizations keep their pipelines serverless and integrated with the rest of the AWS analytics ecosystem. ETL jobs ensure that data is not only stored but also structured for efficient analysis. Glue includes Glue Studio, a visual environment for designing ETL jobs without writing extensive code. With drag-and-drop workflows, analysts can define transformations and job flows more intuitively, while engineers can still extend them with custom scripts. This reduces barriers for teams with varying levels of technical skill, making ETL processes more collaborative. Similarly, Glue workflows allow orchestration of multiple jobs, coordinating dependencies, and scheduling pipelines. This orchestration ensures that transformations occur in the right order and that downstream analytics always have fresh, prepared data. Another advanced feature is the Glue Schema Registry, which provides centralized schema management for streaming data. It integrates with services like Kinesis and Kafka, ensuring producers and consumers agree on data structure. By enforcing schemas, the registry prevents data quality issues and ensures compatibility across pipelines. This is especially important in environments with many streaming sources, where inconsistent data formats can easily break analytics pipelines. The Schema Registry extends Glue's governance role from static S3 datasets to dynamic event-driven architectures. Security is foundational across both Athena and Glue. Access is controlled through IAM permissions, which determine who can query data or manage catalog objects. Data at rest can be encrypted with KMS, while traffic to and from S3 can be secured with TLS. For workloads requiring isolation, Athena queries can run within VPC endpoints to keep traffic on private networks. Together, these features ensure that analytics do not compromise compliance or security posture, even as they democratize access to data. Athena and Glue integrate with a wide range of AWS services. Common integrations include CloudTrail logs, which can be queried for security audits, ELB logs for performance analysis, and application-generated data for business insights. By connecting seamlessly with S3, these services become the analytic layer for nearly any data stored in AWS. The richness of integrations ensures that organizations can unlock value from existing datasets without migration, making Athena and Glue accessible starting points for analytics in the cloud. Despite their strengths, common pitfalls exist. The small files problem is a frequent issue, where datasets consist of many tiny files that overwhelm Glue crawlers and make Athena queries inefficient. Similarly, relying on uncompressed text formats like JSON or CSV drives up query costs due to the volume of data scanned. Organizations must plan their storage layout using columnar formats, compression, and file consolidation to avoid these traps. Recognizing and mitigating these pitfalls ensures Athena and Glue deliver the promised combination of simplicity, performance, and cost efficiency. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When building modern analytics architectures, many organizations adopt a lakehouse pattern combining S3 for storage, Glue for metadata management, and Athena for querying. In this setup, S3 serves as the central data lake, Glue catalog provides the schema definitions, and Athena enables SQL queries without moving data. This pattern balances flexibility with governance. Raw data can be ingested cheaply into S3, structured with Glue, and analyzed immediately through Athena. It also supports multi-tool access, since other AWS services like Redshift Spectrum or EMR can consume the same Glue catalog metadata, ensuring consistent governance. Athena queries often start with create external table statements, which register S3 data into the Glue catalog. Alternatively, Athena supports CTAS, create table as select, workflows, which allow you to run a query and write its results back into S3 in a more optimized format, such as Parquet. CTAS is particularly useful for reformatting raw CSV logs into efficient columnar storage, improving subsequent query performance and lowering costs. By iteratively transforming datasets with CTAS, analysts can refine raw ingestion into structured, performant datasets directly in the lake. To further optimize queries, Athena supports partition projection, which avoids scanning metadata from millions of partition files. Instead of listing each partition explicitly, Athena can calculate partitions based on naming conventions, such as dates embedded in S3 prefixes. This dramatically reduces query planning time and cost for very large datasets. For example, if logs are stored as S3 skeptical smiley face / logs per year equals 2024 per month equals 08 per day equals 15, partition projection lets Athena infer partitions rather than crawling them. This makes querying vast, time series datasets efficient and cost-effective. Storage layout directly influences cost, so compression and columnar formats are essential. By storing data in Parquet or ORC with snappy or gzip compression, the amount of data scanned per query can shrink by 10x or more compared to raw CSV. File sizing also matters. Datasets composed of thousands of tiny files slow queries and inflate costs due to planning overhead. Best practice is to consolidate files into larger chunks, often 128 megabytes or more, to align with distributed query engines. These design decisions format, compression, and sizing turn Athena into a practical tool rather than an expensive one. Cost optimization in Athena also depends on query discipline. Because Athena charges by data scanned, selecting only needed columns and applying where clauses to prune data are critical. Running select asterisk across terabytes of data is wasteful and costly, whereas targeted queries may scan only gigabytes. Similarly, using limit clauses during exploration prevents accidental full dataset scans. These practices transform Athena from a blunt tool into a precise instrument, ensuring queries deliver insights without unnecessary expense. Governance becomes even more powerful when integrated with AWS Lake Formation. Lake Formation builds on the Glue catalog by adding fine-grained access controls, allowing administrators to restrict which users can see specific tables, columns, or rows. This enables centralized data governance across multiple analytics tools, from Athena to Redshift Spectrum. For example, HR teams may have access to salary data while finance teams are restricted to anonymized aggregates. Lake Formation ensures compliance and security while still enabling self-service analytics, reducing the need for manual permission management. Glue ETL jobs can be made more efficient with bookmarks, which track process data and allow for incremental ETL. Instead of reprocessing the entire dataset each time, Glue only processes new or updated files since the last run. This reduces costs and shortens job times, particularly in pipelines that ingest continuously updated data. For instance, daily logs arriving in S3 can be incrementally transformed without reprocessing historical files. Bookmarks transform Glue from a batch processor into a more intelligent, incremental system. Scheduling and reliability are built into Glue. ETL jobs can be scheduled to run at defined intervals or triggered by events such as new file arrivals. Glue provides retry mechanisms and error handling to ensure robustness, restarting failed jobs, or escalating alerts. Combined with orchestration tools, this ensures that pipelines run predictably. Instead of manually starting jobs, organizations can trust Glue to execute according to policy, reinforcing automation as a core principle of data lake operations. Complex pipelines often require orchestration across multiple steps. AWS services like step functions and Event Bridge integrate with Glue to provide workflow automation. For example, a step function might trigger a Glue crawler, launch a transformation job, and then notify analysts when data is ready in Athena. Event Bridge can trigger Glue jobs directly when new files land in S3, creating event-driven architectures. These integrations ensure that pipelines remain responsive, automated, and resilient, minimizing manual coordination. Observability is critical in analytics pipelines. Glue jobs generate detailed logs and metrics, accessible through CloudWatch, while Athena provides query histories and execution details. Together, they allow teams to monitor performance, detect failures, and track data freshness. Observability ensures that analytics are trustworthy. Stakeholders know not just the results, but when and how the underlying pipelines last ran. Without this transparency, confidence in analytic insights can erode, making monitoring an essential operational layer. Cross-account data sharing is increasingly common in multi-team or multi-organization environments. With lake formation cross-account permissions, data catalogs can be shared securely without duplicating data. Athena users in different accounts can query the same datasets under controlled access policies. This enables collaboration while maintaining central governance. For example, a central data team may share curated datasets with multiple business units, ensuring everyone works with the same definitions and controls. Despite their strengths, pitfalls remain common. Mismatched schemas between datasets can break queries or transformations, especially when glue crawlers infer inconsistent structures. Missing partitions lead to incomplete query results, causing confusion or inaccurate analytics. Small file proliferation inflates costs and slows queries. These pitfalls highlight the need for governance and operational discipline, ensuring that data lakes don't become data swamps. Careful schema management, file layout, and partition strategies are as important as the tools themselves. From an exam perspective, the distinction is clear. Athena is the tool for query and play SQL analytics directly on S3. Glue provides the data catalog, schema inference, and ETL needed to organize and prepare that data. If the question emphasizes querying logs or ad hoc exploration, Athena is the answer. If the focus is on structuring, cataloging, or transforming datasets, Glue is the service in play. Together, they provide the foundation for efficient, governed, and cost-conscious data lake architectures in AWS. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.